You know, we're bombarded with stats and data every single day, right? In the news, in ads, everywhere. But what story are those numbers really trying to tell us? Well, in this explainer, we're going to give you the essential tools you need to look past the flashy headlines and find the actual truth.
All right, let's kick things off with a classic real-world problem. Imagine a business school. They're super proud of their graduates, and they want to put out an ad saying what their average starting salary is. They've got the numbers for 12 recent grads. Seems pretty straightforward, doesn't it?
Okay, but here's where it gets a little weird. Using that exact same list of 12 salaries, we can come up with two totally different averages. One is $3,940, and the other is $3,905. So what is going on here? How is this even possible? And more importantly, which number is telling the real story about how well these graduates are doing?
Well, the answer to that puzzle is that there are actually a couple of common ways to find what we call the center of a data set. Let's break down the two heavy hitters, the mean and the median.
So that first number we saw, the $3,940, that's what's called the mean. This is the one you definitely remember from school. It's the average we all know and love. You just add everything up. In this case, all 12 salaries add up to $47,280, and then you divide by how many things you added, which is 12. And voila, $3,940. But here's the thing about the mean. It's got this one major flaw. It's super sensitive to what folks in the stats world call outliers. Those are just numbers that are way higher or way lower than the rest of the group. So for instance, what if just one of those graduates lands an absolute superstar job and starts making $10,000?
And just like that, boom, the mean salary shoots all the way up to $4,413. That's a jump of nearly $500, all because of one person's amazing salary. Now, if the school used that number in their ads, wow, that would be seriously misleading about what a typical graduate actually earns.
And that's where our second tool comes in, and it's a much more dependable one, the median. Think of the median as the true middle-of-the-road value. You just line up all your numbers from smallest to biggest and pick the one smack dab in the center. For our 12 salaries, that's $3,905. And get this, even with that crazy $10,000 outlier in the mix, the median doesn't budge. It stays right at $3,905. It's not easily fooled.
Okay, so the median is great, right? It gives us a way more reliable sense of the center. But honestly, that's only half the story. To really get what the data is telling us, we also need to know its spread. I mean, are all the data points huddled together, or are they kind of scattered all over the map?
To get a feel for this, just imagine a place we'll call Town A. The temperature is incredibly consistent, 20 degrees, 21, then 22. The average temperature is a perfect 21 degrees Celsius. Super predictable. You know exactly what to wear.
Okay, now let's hop over to Town B. And get this, it has the exact same average temperature of 21 degrees. But look at the difference. The weather goes from a chilly 11 degrees all the way to a scorching 31. You'd be packing shorts and a winter coat for this trip. See, same average, but a completely different world. And that right there is why spread is so important.
So how do we actually measure this spread? Well, for that, we have something called standard deviation. It basically boils down to a single number that tells you, on average, how far each data point is from the center, from the mean. A tiny standard deviation means everything's bunched up, like in calm town A. A big one means it's all over the place, like in chaotic town B.
All right, so we've got the center and we've got the spread. Now with just those two things, we can do something really cool. We can take any single piece of data and figure out exactly where it fits in the big picture. And the magic tool for that job is called a z-score. You can think of a z-score as a kind of universal translator for data. It takes any value from any dataset and tells you how many standard deviations it is away from the mean. This is what lets you compare apples and oranges, like your score on a history test versus your friend's score on a math test.
And you know what? Figuring out a z-score is actually a really simple three-step deal. In this example, we see that a class size of 54 has a z-score of positive 1.25. And right away, that number tells you a story. This class is significantly bigger than average, more than one full standard deviation bigger, in fact.
Okay, but what about when the data isn't just a simple list of numbers? What if we're looking at something that grows or changes over time, like an investment? This is where we have to be super careful about picking the right tool from our toolkit.
Because if you're talking about something like finance, where your returns build on each other year after year, using that plain old arithmetic mean we talked about at the beginning, well, that can give you a really skewed, overly rosy, and just plain wrong picture of how things are going.
Just take a look at these annual returns for a mutual fund. I mean, it is all over the place, right? A total roller coaster of ups and downs. And the key thing to get here is that this isn't just adding and subtracting. Each year's return multiplies a result from the year before. It's a compounding process.
So for this exact type of problem, there's another special tool, and it's called the geometric mean. It was literally made to find the true average rate of change when things are multiplying or compounding over time. And man, the difference is huge. If you use the simple mean, you'd think your initial $100 grew to over $163. But the geometric mean, the correct tool, shows you it actually only grew to about $133. We're talking about a $30 difference on a $100 investment. That's the difference between a slick sales pitch and what's really in your bank account.
Okay, so let's wrap this up and review our awesome new statistics toolkit. First off, whenever you hear the word average, your first question should be, wait, is that the mean or the median? Second, if the data has some crazy high or low numbers, you know the median is going to be your best friend. Third, remember that the spread is just as important as the center. Fourth, use z-scores to figure out where any one thing stands in the crowd. And finally, for anything involving growth over time, you gotta use the geometric mean. No exceptions.
So there you have it. You are now armed with the basic but super powerful tools to be a much smarter consumer of data. The next time you see a number in an ad or a news report, you won't just take it at face value. You can ask the right questions. The real question is, now that you have these tools, how are you going to use them to cut through the noise and spot the misleading stats all around you?